Welcome to my kcse revision channel. Teacher Marita, Girls Boys High School. Kindly subscribe, click the notification bell such that you get notified once I upload a new video. Today we are looking at some of the questions that can be said from chlorine and its compound. Here I have done some summaries. So I have the first diagram where we have a dry chlorine gas passed through water under the inverted funnel. Then also we have another one here where we have a reaction of chlorine gas with hydrogen sulfide. Then what are the expected questions? You can also have a reaction of the properties of chlorine gas as you can see on this diagram. And then finally we have the preparation of hydrogen chloride gas. In our first diagram, we have dry hydrogen chloride, and this one is passed through water under the presence of the inverted funnel. So what are some of the expected questions that we are expecting to get from this particular diagram? The purpose of this inverted funnel, we know that chlorine dissolves in water, and the purpose of the inverted funnel is to provide the land surface area over which the hydrogen chloride gas dissolves in water. So if you will be asked to state the purpose of the reason why we have this inverted funnel, the inverted funnel is just increasing the surface area for the hydrogen chloride gas to dissolve in water. Now, when a blue litmus paper was dropped into a saline solution, that is when hydrogen chloride gas is dissolved in water, there is an adsorbing solution. And of course, the resulting solution is the formation of the hydrochloric acid. So when a blue litmus paper was dropped into a saline solution, it turns red. You were supposed to explain or to state the reason why, or to explain the observation why that the blue litmus paper turns in this case red. So what you need to understand is that hydrogen chloride gas in water is normally ionized into hydrogen ions. The hydrogen ions now, in the presence of these hydrogen ions, it makes the water acidic. So the water will become acidic because of the presence of these hydrogen ions, whereby now the litmus paper in an acidic solution, a blue litmus paper turns red. So you just say in water, hydrogen chloride dissociates into hydrogen ions. The presence of hydrogen ions makes water acidic. The blue litmus paper turns red in an acidic solution. So those are some of the expected responses and observation you can make from this particular diagram. So if you will be asked, you state the observation, you give a reason why the blue litmus paper turns red, that's what you can say. And of course, the purpose of the inverted funnel, whereby it increases the surface area for the hydrogen chloride gas to dissolve in water. We have another diagram here where we have the chlorine gas reacted with hydrogen sulfide gas. So we have this chlorine gas, then we have the hydrogen sulfide gas, and then of course we have this gas X. You are expected to know what is this gas X, or to write an equation for the production of this gas X. Now, in this experiment here, first question you are supposed to state and explain the observation which is made in the boiling tube. We can have this boiling tube here, where we have the hydrogen sulfide, and then we have a chlorine gas. What do you understand here? That the hydrogen sulfide gas will just combine with chlorine to form a yellow precipitate of sulfur, and then of course we have the hydrogen chloride gas. So this gas X is normally hydrogen chloride. So we have, this is the X here. This is the hydrogen chloride gas. So what is the observation here? The observation in the boiling tube, you can see a dimples of a yellow solid are observed in the sides of the gas chamber. That is the observation you can see in this boiling tube. Why do we have this yellow solid? The yellow solid is because the hydrogen sulfide is being reduced to sulfur. It is being reduced to sulfur, which is a yellow precipitate or a yellow solid. And now chlorine gas is normally oxidized to is reduced. Chlorine gas is normally, this one is oxidized by this chlorine. The chlorine gas also reduced that. So we can see that you have a yellow precipitate of saliva, and then you have the chlorine, the hydrogen chloride gas. So we can have hydrogen chloride gas, and then of course you have a yellow precipitate of a yellow solid of saliva. Now you are supposed to also name gas X. Name gas X is normally hydrogen chloride gas. When you are required to write the equation of the reaction, candidates place in the boiling tube, you write a correct chemical equation with the correct state symbols and a well-balanced equation. So you will have the hydrogen chloride, hydrogen sulfide combining with chlorine. You have saliva, and then you have hydrogen chloride gas. Sometimes also you will be required to state the precaution or which precautions will be taken while handling this kind of an experiment. So the precaution which is taken here, the experiments will be carried out in a fume chamber because the chlorine gas and the hydrogen chloride, hydrogen sulfide gases are poisonous. So the precaution is the experiment should be carried out in a fume chamber because the gases are poisonous. Gases like hydrogen sulfide gas and the chlorine gas, hydrogen chloride gas are poisonous. So the experiment must be carried out in a fume chamber. In the next diagram, we have a chlorine gas. This is testing the properties of chlorine gas, a reaction of chlorine gas with metal. And in this case, we have our chlorine gas, then we have aluminum metal, we have the calcium oxide, we have heat, and then we have solid P. This solid P is normally aluminum chloride, whereby when chlorine combines with aluminum, it forms aluminum chloride. And aluminum chloride, it collects at this far end here because it's a supplement. So we will be asked to give the property that makes this solid P to be collected at this far end. You just say it sublimes when heated. That is the property that makes this solid to be collected here. Also, in place of this aluminum, you can also use the iron metal. So instead of collecting the aluminum chloride, you can also collect the iron 3 chloride. In this case, if you are using this metal as an iron metal. Now, what are some of the expected questions you are expecting from here? You are supposed to name substance P. Substance P, of course, is here, as I've already said. It's when we have chlorine gas combining with aluminum, and therefore you combine, you get this solid as aluminum chloride. So the solid P is just aluminum chloride. It is collected in this far end here because it is a supplement, or the property makes it to be collected at that far end. It is sublimes when heated. So in place of this aluminum, you can also use iron metal. So the iron will just combine with chlorine, and then you collect that solid at iron 3 chloride. Write an equation for the reaction that took place in the combustion tube. In the combustion tube, we have chlorine gas. We have chlorine gas passed through anhydrous calcium chloride, and the purpose of anhydrous calcium chloride in this case here is used to dry the gas. So you will have a dry chlorine gas. Then you have aluminum. It combines now, we collect the aluminum chloride. So we have just aluminum, then plus chlorine, you have aluminum chloride. In this case, you are supposed to write a correct chemical equation that contains the state symbol and well balanced. State the function of the anhydrous calcium chloride and calcium oxide. So we have calcium oxide here, and then we have anhydrous calcium chloride. So the purpose of anhydrous calcium chloride here is just to dry chlorine gas. Then we have calcium oxide. The purpose of that calcium oxide, first of all, it prevents the entry of atmospheric moisture from entering the apparatus, and it can also react with chlorine gas. So the advantage calcium oxide has over calcium chloride is that apart from preventing the entry of that atmospheric air, it also reacts with excess chlorine gas. Now, why is it necessary to pass a chlorine gas through the apparatus before heating begins? Why is it necessary that you are passing the chlorine gas through the apparatus before the heating begins. So inside here, initially there was some air or there was some oxygen. So the reason why we are passing the chlorine before the heating begins, it is to expel all of the air, or you can expel all of the oxygen that was initially in the apparatus, which could otherwise react with aluminium to form the aluminium oxide. So it just said to expel all the oxygen or to expel all the air from the apparatus that will react with aluminium to form the aluminium oxide. And that is the reason why it is necessary to pass a chlorine gas through the apparatus before heating begins. Why calcium oxide is preferred to calcium? Why calcium oxide is preferred to calcium chloride in the gut tube? So in this gut tube, the calcium oxide is preferred. As I've said earlier, that the calcium oxide it has an added advantage over the calcium chloride, whereby it can react with the excess chlorine. So it's just simply saying that it reacts with the excess chlorine, and in this case now preventing that chlorine from entering into the atmosphere. Write the equation that takes place in the gut tube. So in the gut tube, the main reaction we have where we have the calcium oxide combining with chlorine, and therefore we can form the calcium chlorate. A correct chemical equation, it must contain state symbols and well balanced. So apart from having the calcium oxide reacting with chlorine, you can also have the calcium oxide combined with the moisture. So if it combines with the moisture, it normally forms the calcium hydroxide. Now, those are the questions that you can expect from this kind of a particular diagram. So I've said that in place of this aluminium and iron metal can also be used. Let us look at a very important diagram. That is the preparation of hydrogen chloride gas or hydrochloric acid in this case. So in this preparation of hydrochloric acid, as you can see from this diagram, you have reagent W, then we have reagent Y. You can when the two can react, they have a flame in this chamber X. Then we have water. It introduced in this under the presence of the gas pits, and then we have the hydrochloric acid being collected. So what are some of the expected questions? One, you are supposed to name the reagents W and Y. The reagents W and Y, in this case, you talk of the raw material or the reagents required for the preparation of hydrochloric acid. And in this case, you talk of a dry chlorine gas, which is W in this case, and also you can talk of a dry hydrogen gas. So, explain the role of the gas pits in this experiment. So the role of the gas pits in this experiment here, it is just to increase the surface area for the absorption in which the gas dissolves in water. And in which gas in this case is the hydrogen chloride gas. So we can have the gas pits increasing the surface area for the hydrogen chloride gas to dissolve in water. Write an equation for the reaction in chamber X. So in chamber X here, what do we have? We have a dry chlorine gas, and of course we have a dry hydrogen gas. So when the two combine, they will just form hydrogen chloride gas. A well-balanced equation with the correct state symbols. Explain why hydrochloric acid formed appears yellow in color. Why is the hydrochloric acid formed appears yellow in color? So the yellow color it indicates that it contains the iron impurities. So if you will be asked to give that reason why is that the hydrochloric acid formed appears yellow in color, it is the color indicates that the hydrochloric acid contains iron impurities. State and explain the observation that could implement when hydrogen chloride gas is coupled through a solution of silver nitrate. What you need to understand that hydrogen chloride gas it dissociates. So the observation first is forms a white precipitate. And why do we have the white precipitate? So first of all, what you can see, the observation is the white precipitate. So what I'm supposed to understand here is that hydrogen chloride gas dissociates in solution to form hydrogen ions and the chloride ions. So the chloride ions combines with the silver ions and then it forms a white precipitate. So you just say hydrogen chloride gas dissociates in a solution, producing hydrogen ions and the chloride ions. The chloride ions react with the silver ions to form silver chloride, which is seen as a white precipitate. And that is the observation you can see when hydrogen chloride gas is pummeled through a solution of a silver nitrate. Kindly you follow my channel, you click the notification bell, you get notified once I upload a new video. Thank you for watching.